We've been talking about ionic compounds, now we're going to talk about molecular compounds. Remember, molecular compounds are composed of nonmetals. We're only going to learn how to name compounds that have two nonmetals. The formula for a molecular compound cannot be readily determined because we're not looking at charges on ions. So the names need to be more descriptive. You can have many molecular compounds formed between the same two nonmetals. An example here is compounds formed from nitrogen and oxygen. There are 6 different unique molecular compounds. So we can't just call this nitrogen oxide, because which one do we mean? So we've got 2 nonmetals. What we're going to do is we're going to use numerical prefixes. They're the same ones we used for the hydrates to indicate how many atoms of each element are present. So we put the more metal-like element first. And usually that's the element with the smallest group number, the one towards the left on the periodic table. If 2 elements lie in the same group, it'll be the element with the greatest row number. Let's see if I have a periodic table. I need a periodic table here. There's one in here somewhere. Okay, this will work. Just need to point at a periodic table. So remember this stair-step line divided the metals and the nonmetals. And so to choose the more metallic element, you're going to find out, well, there's a diagonal trend here, right? So if we're comparing nitrogen and fluorine, which one is closer to the metal side? It's nitrogen. If you're looking at oxygen and sulfur, which is closer to the metals? Well, it's the sulfur, okay? That's how we decide which element is listed first, okay? Now, you're not going to have to make that decision very often, so don't worry about that too much. So we use these numerical prefixes to say how many of each element. So we are learning to name binary molecular compounds. Binary means 2, so these have 2 elements. So the general form for these names is there's a prefix and the name of the first element. That's the more metallic one. And remember, I think of metals as being masculine. So this is the one that's more masculine, and this is the one that's less masculine. This is the second one. And a prefix to indicate how many of the second one. And just like the monatomic ions for nonmetals, these elements are going to change the ending of their name to -ide. They're not ions, but they're still becoming part of this compound, and so they change the end of their name. There are a couple of oddities about how we do the prefixes, and the one that I want you to remember is this one. If there's only one atom of the first element in the formula, we leave the prefix mono off. We use the prefix mono for the second element, but we don't use it for the first one. And that just follows in with chemists avoiding the number 1, right? So the example given here, NO2, there's only one nitrogen, but because that's the first one, we don't call it mononitrogen dioxide, just nitrogen dioxide. The di comes from the 2 oxygens. Another thing I want you to be aware of is that water, H2O, has the common name water. Okay, its scientific name would be dihydrogen monoxide, which is always fun to, scare people with. My teacher made us drink dihydrogen monoxide today. I thought I was going to die. Right? It sounds real scary. Made you drink water. Yeah, it's good for you. So we always call this water unless we're trying to scare our friends or our parents or something. This would have the systematic name nitrogen trihydride, but this compound is also extremely common, and so we never call it that. We always call it ammonia. Okay? So you will be expected to know the formula for ammonia and the formula for water. They're listed right there. Okay, so let's practice this a little bit. The molecular compounds usually don't cause students too much trouble. So let's name this one that N2O5. So what's the prefix for 2? Di. So we put di in front of the first element's name, dinitrogen. And what's the prefix for 5? Penta. So this would be dinitrogen pentaoxide. That's not too bad. Sometimes you will see that this ending vowel on the prefix gets dropped when the element's name begins with a vowel to avoid double vowels. Pentaoxide or pentoxide, I've seen it both ways, right? Things like monooxide, like CO, is carbon. We don't put the mono on that because that's the first one. Monooxide, this double O looks really weird, right? Is that monoxide? What is that? So especially with this combination, mono and oxide, we drop one of those O's and we say monoxide. Sometimes that will happen with the A. I will not try to trick you on that one, okay? So just be aware if you see it different, it's just different. Okay, let's write the formula for phosphorus tribromide. What's the symbol for phosphorus? P. How many phosphorus atoms are there? Just one. It doesn't say mono because we leave the mono off, but it doesn't say anything else, so it's just one. And then tribromide, what does that mean? 3 BRs. So BR, and the 3 is a subscript after the element symbol. Okay, any questions? Molecular compounds. The other category, we've talked about ionic and molecular compounds. The other category are acids. A very simple definition of acids is that acids are molecular compounds that release hydrogen ions when dissolved in water. So these are not ionic compounds, they are molecular compounds. When we put them in water, they release hydrogen ions, so when they're dissolved in water, we name them as acids. We can recognize acids from their formula because they always have hydrogen, and the hydrogen is generally written first in the formula. So if you look at a formula and it starts with H, that's probably an acid. Now, is H2O an acid? No. We don't name it as an acid, no. HCl. HCl is a molecular compound. It's formed of 2 nonmetals, and so it can be named as a molecular compound. In its pure form, it would be a gas at room temperature, and it would be called hydrogen monochloride. When it's dissolved in water, it forms hydrogen ions and chloride ions. The AQ here means aqueous, dissolved in water. So when it's dissolved in water, it's named as an acid. The compound is not considered an acid if it does not dissolve in water. And there are some compounds that will not dissolve in water. And so even though they may have an H in their name, they're not necessarily an acid. So if you see a compound that begins with an H and it says AQ, then we're going to name it as an acid. Some characteristics of acids. Acids have a sour taste. They will dissolve many metals, not all metals. Here's an example of zinc metal dissolving in hydrochloric acid. And so we see this bubbling hydrogen gas is being formed, and this zinc strip is going to gradually disappear. It's dissolving. The formulas of acids generally start with an H, so like HCl, H2SO4. So there's 2 different kinds of acids, and they have different patterns to their names. Oxyacids as the name suggests, are acids that contain oxygen, oxyacids. The book refers to the other type as binary acids, those that contain only two elements. I'm not real crazy about that title because there is an acid that falls into that naming category that has three elements in it. So that kind of bugs me. So I call them oxyacids and not oxyacids. So what the book calls binary acids, these are the ones that do not have oxygen in them. The pattern for these names is it starts with the prefix hydro, and then you take the name of the nonmetal and you change the ending to ic, and then you add the word acid at the end. So hydro, whatever the element name is that's not hydrogen, and then acid. We change this ending to ic. So let's look at an example. So here we have HF, in parentheses it says AQ, meaning this is dissolved in water. So we're going to name it as an acid. Does this have oxygen in it? No. So we're going to use the prefix hydro. So this is going to be hydro, and then we need the name of, there's hydrogen and another nonmetal, and the other nonmetal is fluorine, right? So we take the word fluorine and we change the ending to ic. So this is fluoric, hydrofluoric acid. Now, a common misspelling with the name fluorine is people will spell it flourine. There's no flour in fluorine. Fluorine is gluten-free, okay? Right? That'll help you remember it. There's no flour in there. It's UO, fluorine. So this is hydrofluoric acid. Any questions? Then the oxyacids. So the oxyacids have oxygen in them. So it's going to be one or more hydrogens and then one of those oxyanions that I told you to memorize. You look at the name of the oxyanion. That will end in ate or ite. And so the pattern here is if the oxyanion's name ends in ate, we change the name, ending of that name to ic. So ate becomes ic. And if it ends with ite, that becomes us. So how the heck are you supposed to remember that? Rick ate him before he could bite us. I didn't leave myself enough space here. Okay, so here's ick and ate. Those go together. Ite and us go together. Another one students like is the white mouse ate icky cheese. So ite and us, ick and ate. Okay? And then we follow up with the word acid. So let's name this one. HNO2. We're going to name this as an acid because it's dissolved in water. We've got the AQ here. It starts with an H. So this one has oxygen in it. So what we want to do is we want to cover up the H and look at what's left. NO2 with a charge on it. What's the name of that oxyanion? Nitrite. Because we memorize nitrate, it's NO3 minus. This has one less oxygen. This is the light version. So this is nitrite. So we change ite to us. Nitrous acid. Any questions? There's no hydro. There's no hydro for this. The hydro is the prefix if there's no oxygen. Okay? Any other questions? Let's write the formula for perchloric acid. There's no hydro in front of this. That tells us this is based on an oxyanion, and this is a derivative of that oxyanion's name. So this has the ending ic. Which suffix goes with ic? 8. So this is an acid that has perchlorate ion in it. Okay, we take perchloric, change ic to 8. We're just doing the opposite of what we're doing up here. We're taking nitrite, going to nitrous. Here we're going the other way around, ic to 8. Perchlorate ion. So we need the formula for that. Well, chlorate is ClO3 minus. Perchlorate has one more oxygen. So this is ClO4 with a -1 charge. That's perchlorate ion. The charge on this ion, and it's always going to be an anion, the charge on the ion tells us how many hydrogens it needs, because hydrogen forms a +1 ion. So we're putting this together with H+ ions. So if it has a -1 charge, we need 1 hydrogen. So HClO4 aqueous. Any questions? So we just did an example of this, but here are the guidelines for that. Writing formulas for acid. Yeah. Question?
What is the AQ?
The AQ means that it's dissolved in water.
So acid.
So it's an acid, if it starts with H. We'll see that lots of things can dissolve in water. We put that AQ there because if it's not dissolved in water, we shouldn't name it as an acid. That is something I will not try to trick you with.
So AQ just means it dissolves in water.
It's dissolved in water, yep. So the nice thing about acids is they're easy to identify. Their formulas start with H, and their names actually have the word acid in them. How convenient is that? So if the name has acid in it, you know it's an acid. You're going to write the formula as if it were an ionic compound, even though it's a molecular compound. Because when it dissolves in water, it does form ions. So when we see the hydro prefix, that means we have a binary acid. So it's just going to be hydrogen and something else, no oxygen. If there's no prefix in the name, then it's an oxyacid. So for the oxyacid, we take an ic ending and change it back to 8. We change an us ending and change it back to ite. So some extra examples. Write the formulas for the following acids. So hydrocyanic acid. Obviously it's an acid. Is it an oxyacid or the other kind? It starts with hydro, so it's the other kind. So hydrocyanic, hydro represents the hydrogen, and then this is the name of the other element. Is there a cyanogen or cyanide or... There's cyanide. Is it an element? No, it's a polyatomic ion. Cn minus. Well, could we make an acid with this? Because this is not an oxyanion, is it? It's a polyatomic ion, but it's not an oxyanion. Well, so that has a -1 charge, so we would need to put 1 hydrogen with that. So that would be HCN aqueous. That is the one example that makes me not like the name binary acid. Does that have 2 elements in it? No, it's got 3 elements in it. So, but it follows the pattern of naming. Any questions about that one? Let's do this one, phosphoric acid. Oxyacid or not? It's an oxyacid because it doesn't start with hydro. So then we're looking at this suffix here. Ic, what do we change that to? 8. So this comes from phosphate ion. We need the formula for phosphate ion. PO4 3-. So this one has a -3 charge. How many hydrogen ions do we need to balance that negative charge? 3. So this is going to be H3PO4. And writing the formula for an acid, we always put AQ after it. Yeah.
Why don't we write the charges?
We don't write the charges in the formulas because we don't need to and because it would make things really cluttered. Any other questions? Okay, how about this one? Hypochlorous acid. Is it an oxyacid or the other kind? It's an oxyacid. Now, sometimes this messes with you because hydro and hypo look a lot alike, right? But it's hypo, not hydro. So, it's got one oxygen. That means the hypo means below. So this is the smallest of the chlorine oxyanions, right? So we change us to ick. No. We change us to ite. It was close. Close only counts in horseshoes and hand grenades. So this is hypochlorite. And she's exactly right. This has one oxygen, ClO minus. The -1 charge tells me I only need one hydrogen. So the formula would be HClO, aqueous. Okay? This is going to take some practice. The good news is there's only a handful of acids. It's not like the ionic compounds where there's way too many to even think about. So there's not that many. So just keep working at it. Once it clicks, you'll be like, oh, that's so simple. You have to push through until it clicks. Yeah.
So on the study guide, the chloride was like ClO2 and then negative. So does it change or?
That's an excellent question. So on the study guide, chlorite is ClO2 minus. That is chlorite. That is exactly right. This is hypochlorite, not hydro, hypo. The hypo means one less oxygen. Yeah, excellent question. I love questions like that because everybody's got these little things that they're stumbling over. And if you ask them in the moment, then you get it straightened out and just everything else is a lot easier. So please, please ask questions. Anybody else have a question? It seems real simple to me because I've been doing this for years and years. But when I first started learning this, it was not simple. It was very confusing. And so I expect a lot of confusion and a lot of questions. And the only way you learn it is by asking questions. You make mistakes, you get corrected, and you figure it out eventually. Acid rain. So there are some topics in the book that relate to topics of common interest or everyday life or the environment. And so some of these I will just skip over. Some of them I will touch on briefly. I'm not going to test you on acid rain. But you've probably heard of acid rain, and you might wonder, well, what the heck is that? How does that come about? So some pollutants, such as nitrogen monoxide, nitrogen dioxide, sulfur dioxide, and sulfur trioxide, can form acids when they combine with water. So there's water in the atmosphere, right? There's humidity and there's clouds, and when it rains, these compounds, along with the water, can form acids. And so that makes the rainwater acidic. Now, is it straight sulfuric acid or sulfurous acid? No, but it's slightly acidic because of these pollutants. So that acid rain falls, and it can do things like this to statues. So here are two statues, and this one has been exposed to more rain than that one, probably because there's a roof or something, and this one's slightly sheltered. And we can see that this one's just been eaten away. Now, it took years and years for that to happen, but still, it's significant. We also see effects like this, where the rain falls on the trees, and that's not great. But acid rain getting into the soil, getting into lakes and rivers, can cause the soil to become somewhat acidic, and that's hard on the aquatic life and the plants.